Okay, the key with derivatives is to basically, we can never forget the chain rule. So when we are taking the derivative of y cubed with respect to x, the chain rule really does apply because the derivative of the outer would make it 3y squared. We've then left the inner y. Then we've got to take the derivative of y with respect to x, which is what turns it into dy dx, which is very easy to forget. The derivative of y is 1. Again, then the derivative of y with respect to x is dy dx. And the derivative of x squared is 2x with respect to x is dx dx. They want to know what does dy dx equal, so I'm going to factor out a dy dx, leaving me with the 3y squared plus 1 equals a 2x. And therefore, a dy dx equals 2x over that quantity 3y squared plus 1. That is E. Number 6 wants dy dx again when x is 2. So let's go ahead and take the derivative of x squared is 2x dx dx. The derivative of x times y is the product rule. My first function being f, my second function being g. So I'm going to do fig plus gif. The derivative of f, or the derivative of x, is 1, leave my g, plus the derivative of g, or the derivative of y, is dy dx, leave my f function. The derivative of 10 is 0. They want dy dx, so I'm going to go ahead and say dy dx times my x equals negative 2x minus a y. Therefore, my dy dx equals negative 2x minus y all over x. They want us to go ahead and plug in a 2 for my x, but what would we plug in for y, right? Well, what we can do is we can say, all right, if x is 2, what is my y? So I'm going to plug in 2 here for x to solve for my y. If my x is 2, I'd get 4, and 2y equals 10, meaning 2y equals 6 and y equals 3. So I'm going to plug in the point 2, 3 to my derivative. That would get me my dy dx equals negative 2 times 2 minus 3 all over 2 equals negative 4 minus 3 all over 2, which is negative 7 halves. Answer A. Let's keep on keeping on. They want the slope, aka dy dx. And they want that at the point. They gave us the point this time, so let's go get it. The derivative of 3y squared is 6y dy dx, chain rule, minus 4x equals derivative of 6 is 0. Again, I'm going to apply the product rule here, that my first function is negative 2x, so the derivative of f is going to be negative 2. Leave my y. And the derivative of g would be dy dx, leave my f function. I'm going to go ahead and get dy dx by itself first. So I've got 6y dy dx. I'm going to add this quantity over since it's negative. So I'm going to say plus 2x dy dx equals negative 2y. I'm going to add over that 4x. I'm going to factor out a dy dx, leaving me with 6y and 2x equals negative 2y plus 4x. Final answer, dy dx equals negative 2y plus 4x all over 6y plus 2x. They wanted that derivative at the point 3, 2. So I'm going to go ahead and plug in 3 for my x and 2 for my y, getting me negative 4 and a 12 and a 12 and a 6, getting me 8 over 18. Divide each of those by 2 and we've got 4/9. Answer B. Okay, the derivative of, sorry, I'm just going to try to pick out a pretty color. The derivative of sine is going to be cosine. Leave the angle, and then we've got to take the derivative of the angle, and the angle is the product rule. Oh boy. So the derivative of the angle would be 1y plus the derivative of y is dy dx, leave the initial function, equals the derivative of x is 1. And they want dy dx by itself. So your initial gut might be to divide by that cosine of xy. And I'm here to say that's not wrong, but because of their answers, it's not going to come out nicely, because let's look at what we've got to do from there. Well, not only did we divide, so we'd have 1 over this cosine, then we're going to subtract that y, then we have to divide by an x again, so we would have kind of two fractions, or dividing by an x is the same as multiplying by 1 over x, so that's something to think about. But I'm going to challenge you to go ahead and distribute right now. Whoops, let's get a marker. Let's go ahead and distribute. So I'd have y times the cosine of xy and x cosine of xy times dy dx equals 1. Then we'd be left with x times the cosine of xy times dy dx equals 1 minus that quantity, leaving me with dy dx. I want it all by itself. Dy dx equals 1 minus the cosine of xy all over the quantity x times the cosine of xy. And that answer is D. All right, they want the second derivative. Oh, snap. All right, we got this. So the first derivative would be 2x. The first derivative of y squared would be 2y dy dx. Don't forget about it. The derivative of 25 is 0. To get dy dx by itself, I would subtract my 2x and I'd divide by my 2y to get dy dx equals negative x over y. You feel me? Okay, so then they want the second derivative. So now I've got to go take the second derivative of this, which is going to be the quotient rule, which is low d high minus high d low all over low low. And they want it at the point 4, 3. So I'm going to plug in a 3 for every y, a 4 for every x. But what do I plug in here? Oh, you know, we're going to plug in a negative x over y for my dy dx right there. So I'm going to substitute in negative x over y for this dy dx. And I've got negative y plus x times negative x over y squared before I've done any substituting. Now I'm going to plug in 4 for my x here and 3 for my y here. So I'd have negative 3 and 4 times a negative 4 over a 3 all over my y squared, getting me negative 3 minus 16 thirds over 9. And because we got multiple choice, we got to keep going. Let's get common denominators up top. That would get me negative 9 thirds minus 16 thirds over 9, which gets me negative 25 thirds divided by 9 is the same as multiplying by the reciprocal. Multiply straight across and we get negative 25 27ths, bada bing, bada boom. Okay, let's think about what this next one is asking. It wants the derivative of y with respect to u, but they gave us a y equation and a u equation. So what if we thought about this saying, well, if I took the derivative of y with respect to his variable, which is x, dy dx, and then I divided that by the derivative of the other function with respect to x, du dx, and taking dy dx divided by du dx, the same as multiplying by dx du, am I left with what they want? I like it. I'm on board. So let's go find dy dx of my first function. That'd be 2x minus 2. Let's go find du dx. Du dx is 2. Therefore, dy du is strictly dy dx over du dx, which is going to be 2x minus 2 over 2. When we divide through, we'd get x minus 1, and we got our answer. All right, they want y prime, which is just another way of saying dy dx. Again, we're going to have to do product rule here, fig plus gif. We'd get derivative of x is 1, leave my g, plus g prime would be 2y dy dx, leave my f. Oh my gosh, we've got to do fig plus gif again, with my f being a 2x, therefore f prime is 2, and g prime is dy dx times 2x. The derivative of 8 is 0. We've got to get dy dx by itself, so I've got 2y dy dx and 2x dy dx equals, move the other things over, negative y squared minus 2y. I'm going to factor out a dy dx, leaving me with a 2y plus a 2x equals negative y squared minus 2y. And therefore, my dy dx is going to be the quotient of negative y squared minus 2y over 2y plus 2x. They want us to evaluate that at the point 1, 2. I'm going to go plug that in, and I'd get negative 4 minus 4 over 2 times 2 plus 2, leaving me with negative 8 over 4 plus 2 is 6. Final answer, negative 4/3. On my answer key for this one, I wrote wow, just because it's a little lengthy, okay? We know the derivative of y squared with respect to x would be 2y dy dx. Then the derivative of this next function is the chain rule, derivative of the outer, leave the inner. So I'm going to have 3x times y plus 1 to the second times the derivative of the inner, and I've got a product rule inside there. So the derivative of f is 1. The derivative, g then stays. The derivative of g is dy dx, leave my f. The derivative of 0 is still 0. Because we need to get the slope or the dy dx by itself, and there are 2 dy dx's on this side, I've got to distribute this thing through so that I can separate my dy dx's. Okay, so we're going to distribute through, but I'm also going to, we're going to just distribute through. So 2y dy dx and 3y xy plus 1 squared. Again, that's me taking 3 times that y and leaving this with it, plus 3x times xy plus 1 squared dy dx, wow, is 0. No kidding, that's no wonder why I wrote that. Okay, now I'm going to move this term over, and so I'd have 2, so I'm going to have 2y dy dx and 3x xy plus 1 squared dy dx equals negative 3y xy plus 1. Is that a squared? Why does that look so terrible? Okay. Then I'm going to factor out a dy dx, and I have dy dx equals, it does not equal, dy dx times 2y and 3x, oh my gosh, this is so silly, xy plus 1 squared equals negative 3y xy plus 1 squared. So sorry, these are overlapping. And therefore my dy dx is negative 3y xy plus 1 squared all over 2y plus 3x xy plus 1 squared. Whoa. Okay, I cannot cancel out an x squared plus xy plus 1 squared because this term doesn't have one. So at this point, I'm going to go ahead and plug in 2, negative 1 to my derivative. And I'm going to hope that I get the right answer. When I plug in a negative 1 for my y, I'm going to get a 3. 2 times negative 1 is going to be negative 2 plus 1 squared. Then I've got 2 times my y, which is negative 2. And 3 times 2 is 6. X times y is negative 2 plus 1 squared. I'm going to give myself more room. And I'm going to have 3 times negative 1 squared, which is 1, over negative 2 plus 6 times negative 1 squared, again, will be 6. I'm left with 3 over 4. That is not only a answer, that is the answer. It's like these almost get more ridiculous as we go along. The derivative of y is dy dx. We're going to have to use the product rule here. I'm going to get 1y and dy dx x plus 2x plus 0. All right, they want dy dx, so I'm going to go ahead and move my 1x dy dx over, so I'm going to have minus x dy dx equals y plus 2x. When I factor out a dy dx, I'd have 1 minus x left equals y plus 2x, giving me dy dx equals y plus 2x over 1 minus x. If x is negative 1, we can plug that in to figure out what our y is. My y would equal negative 1y plus 1 plus 1. So 2y would equal 2, and my y would be 1. So I'm going to evaluate this at the point negative 1, 1. When I plug that in, I'd get 1 minus 2 over 1 plus 1, which is negative 1/2. My final answer, negative 1/2. All right, if you keep needing more practice, these are great questions for us. The derivative of x cubed is 3x squared. I'm going to use the product rule here. The derivative of f would be 3, leave my g. G prime would be dy dx, leave my f. The derivative of 2y cubed is 6y squared dy dx. Derivative of 17 is 0. All right, they want dy dx by itself. So I've got 3x dy dx and 6y squared dy dx equals negative 3x squared minus a 3y. Dy dx factored out leaves me with a 3x, a 6y squared, and finally my dy dx is negative 3x squared minus 3y over 3x plus 6y squared. And you're saying, why don't I see the answer? Well, do you agree that every single term has a factor of 3 in common? If I took a factor of 3 out, I would have a negative x squared, a negative y, an x, and a 2y squared. So I'd have a negative x squared minus a y over an x plus a 2y squared. And when I look at that, I see A, and what they've done in A is they've factored out the negative from the top. So if they factor that out, it would get distributed back in. And because they made sure to put it right out front, and that really implies that there are parentheses around it, that it would get distributed in, and that'd be what we started with. Oh man, the product rule really throws a wrench in this one, because when you take the derivative of tangent, and we know it's secant squared, you might be inclined to say answer B. But watch how this plays out. We got to say secant squared of my angle times the derivative of my angle, and again I've got product rule. So I'd be left with 1y and dy dx times x. The derivative of x is 1. And they want dy dx by itself. So again, I'm going to go ahead and distribute this through. So I've got y times secant squared of xy plus x secant squared of xy dy dx equals 1. I'm going to subtract over the y times secant squared of xy. I'm going to divide out, so I've got dy dx equals 1 minus y times the secant squared of xy all over x times the secant squared of xy. And I'm thinking, that doesn't look like an answer. But when I split this division up and I say, this is equivalent to saying 1 divided by x secant squared xy minus y secant squared xy divided by x secant squared xy. Could something cancel out? Well, what is 1 over secant squared? 1 over secant squared, that turns into, give myself some space, a cosine squared of my angle. And I still have that x in the bottom because the only thing I did is I said 1 over secant squared xy. 1 over secant squared is the same as the cosine of the angle. Leave the x. Then I've got to say minus. Then we're doing y secant squared xy all over x secant squared xy. So the secant squared xy's can cancel, and I'd be left with my y, and the x was already down here, y over x, leading me to answer E. All right, the derivative of y squared is 2y dy dx. We're going to use the product rule. The derivative of negative 2x is minus 2. Leave the g. And the derivative of g is dy dx. Leave the f. The derivative of 16 is 0. I'm going to keep the dy dx's on the left side. I'm going to move over the 2y. I'm going to factor out a dy dx. And when I factor that out, I'd be left with 2y minus 2x equals negative 2y. My dy dx would be 2y over 2y minus 2x. What do these all have in common? We can factor 2 out of all of them, leaving me with a y over y minus x. All right, the derivative of x is 1. And then we're going to do the product rule. They love to make you do the product rule with implicit differentiation. The derivative of 2x is 2. Leave the g. And the derivative of g times my f function minus the derivative of y squared would be 2y dy dx. The derivative of 2 is 0. Factor out a dy dx. I'm going to go ahead and factor out because I think we can handle it, as well as move my 1 and my 2y over, leaving me with a dy dx of negative 1 minus 2y over 2x minus 2y. They want us to evaluate this at 1, 1. When I do, I'd have negative 1 minus 2 times 1 over 2 times 1 minus 2 times 1, getting me negative 3 over 2 minus 2. Getting me negative 3 over 0. And what we don't see in option E here is non-existent is the last option. I don't know why they didn't copy, but that is the answer because we cannot divide by 0. All right, the last question. Let's go ahead and take the derivative. We get 2x. I'm not even going to prep you. The derivative of x times y, because of the product rule, is 1y plus dy dx times x. The derivative of y cubed is 3y squared dy dx. The derivative of 0 is 0. They want us to get dy dx by itself. I'm going to factor out my dy dx from my x and 3y squared. I'm going to throw the 2x and the y on the other side, leaving me with dy dx is negative 2x minus y over x plus 3y squared. Let's see. Where do we see that as an answer? I'm tempted by A. Why does that negative out front make sense? Because if I pull that negative out front, I do change the signs of what's up top. Because what this means is I would be multiplying by a negative 1. And when I distribute that through, I would get what I started with.